Hi kids, so Ms. McQuaid here. I would like for you to please take out a fresh sheet of paper. We're going to start a new unit today, and your homework is going to be these notes. So I'm going to check that you have this done, but really it's your own practice. So please write down Unit 5, Moles and Chemical Reactions. That's our new title. All right, please take out your reference tables as well and flip to the periodic table of the elements. All right, so atomic mass. Atomic mass can be found in the top left corner of the box for each element on the periodic table. So I screenshot the key here, and what you'll see is that the atomic mass is in the top left corner. Now remember, this is the weighted average of all of the possible isotopes that exist. So 12.01 is the average, but we're always going to be using this average. All right, so now you have your reference table out and you see where we're looking at the masses. This is where we're going to look at. All right, so let's find a few atomic masses. So go ahead and copy down these elements and pause the video. Now find the mass of each element. Pause the video. All right, now that we're back, I'm going to have you check your answers. Ready? So lithium is going to be 6.94, beryllium 9.01, magnesium is 24.31, hydrogen is 1.01, carbon 12.01, nitrogen 14.01, oxygen 16.00, and chlorine 35.45. Now, we look at these. If you notice, they're all rounded to the hundredths place. So I've rounded all of these to 2 places after the decimal. That's how we're going to round all atomic masses during this unit. So you get used to rounding to 2 places after the decimal. So whatever you have as your answers, make sure that you see how I've rounded them. So for example, nitrogen 14.01. Take a look at nitrogen. In your reference tables, it says 14.0067. So I've rounded it to 14.01 because that 0 is going to get promoted to a 1 because the next value is a 6. All right, now let's think about the units. I'm just going to grab my pen here. Now the unit is an atomic mass unit. The symbol for an atomic mass unit is just a U, and that stands for unit. Now remember, an atomic mass unit is the same as the mass of 1 proton. Oh, I made a little script U there. That's a mu, really. All right, so I'm going to go ahead and add my U's for unit, an atomic mass unit, which means that that's the mass of the same as the mass of 1 proton or 1 neutron. Remember, electrons have no mass. All right. Now, next page. Chemical formulas. The chemical formula of compounds are written as the combination of symbols. So every element has a symbol. That symbol always begins with a capital letter. And if it's a 2-letter symbol, it will have a lowercase for the second letter. It's very important that you write the chemical formulas properly. So, for example, H2O means that there are 2 hydrogens and 1 oxygen. So if we just have 1, we don't multiply. There's no need to put a 1 subscript, but you need to know that the 2 is referring to the hydrogen. So the subscript comes after the symbol for the atom for that element. Now in C6H12O6, how sweet it is, glucose, we have 3 different elements. We have carbon, hydrogen, and oxygen. Now I have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in 1 molecule of C6H12O6. Now, if it is something like this where we have NaCl, there's just one of each. No need for a subscript if we have one. How many carbons are there here? How many oxygens are there here? Now, if you have parentheses, you're going to distribute those parentheses. So this 2 means that I have 2 phosphate ions, 2 times PO4. So I'm going to have 3 calcium atoms, but I'm going to have here 2 phosphorus and 8 oxygens. So I'm going to have 2 of those polyatomic ions. Each polyatomic ion has 1 phosphorus and 4 oxygens. So the parentheses on the outside of a polyatomic tell me that I'm going to have 2 phosphorus and 8 oxygens. Since I have 2 hydrogens and 1 oxygen, 2 hydrogen and 1 oxygen, I have altogether 3 atoms here. So please add that. Here, since I have 6 carbons, 12 hydrogens, and 6 oxygens, all together I have 6 plus 12 plus 6, which makes 24 atoms altogether in that molecule. All together. Forgot about that. I do this to show myself that I'm multiplying. I'm going to be distributing. So, to find what we call the formula mass, which is the mass of the entire compound, we just add up the atomic masses found in that compound. So, please write down these examples. Pause the video if you need to. All right, so finding the formula mass. When we say the formula mass, we say that the chemical formula is a combination of symbols, letters, and numbers that make up that tell us how many atoms of each element are composed in the compound. So what I do is I make a little chart like this, where I say element and the mass and the total. So for example, carbon monoxide is 1 carbon and 1 oxygen. So my chart looks like this, where I say carbon has a mass of 12.01 and oxygen has a mass of 16.00. I add them together. Carbon monoxide has a total mass of 28.01 AMUs. Go ahead and try to do lithium fluoride, hydrogen chloride, and magnesium oxide on your own. Pause the video. Now that we're unpaused, you can check your answers. Lithium has a mass of 6.94 and fluorine has a mass of 19.00. So when I add those values together, I get 25.94 AMUs. HCl, hydrogen has a mass of 1.01 and chlorine has a mass of 35.45. When I add those together, I get 36.46 AMUs. Oh, magnesium oxide. I don't have it written down here, but magnesium has a mass of 24.31. And since oxygen is 16.00, altogether you should have gotten a total mass of 40.31. All right, so now this is where things get really interesting. If there is a subscript, multiply the mass times that subscript. If there is a subscript, multiply the mass times that subscript. So, in water, I have 2 hydrogen atoms. I have 1 oxygen atom. The periodic table of the elements just shows me the mass of each hydrogen. So, since there are 2 of them, I'm going to have to multiply my mass of hydrogen by 2. So go ahead and set up your table again. This time, on my table, I'm going to have element, the number of times that element appears, the number of atoms of that element in my compound, the mass, and the total. So, for example, for water, water has 2 hydrogens and 1 oxygen. So I put hydrogen and oxygen here. My numbers are dictated by the subscripts, 2 hydrogens, so I put a 2 here. I only have 1 oxygen. I put the mass here for my periodic table of the elements, and then I multiply across, where I take the 2 times 1.01, so altogether my hydrogens have a mass of 2.02. Oxygen, 16.1 is 16.00, so altogether water has a mass of 18.02 AMU. Our next example is CO2. So go ahead and make your table, element, number, mass, total. Put your elements, carbon and oxygen, onto the table. Now we have 1 carbon atom and we have 2 oxygen atoms. Find the mass of carbon and find the mass of oxygen from the periodic table. When you're done, you should see that you have a total mass of 44.01 AMUs. Do the same thing for C4H10 and H2SO4 and pause the video. MgCl2 should be 95.21. Oh, I changed the compounds. My bad.